polyploid. Polyploid means it has more than a normal number of chromosomes. You and I, we're diploid. That means we have two sets of chromosomes, one from our dad, one from our mom. And this plant has four. Well, it's not just that this plant has four sets of chromosomes, but it's also that we have a pretty good idea where this plant came from. You see, one of the ways plants can form new species is through polyploid speciation events. And this plant appears a little bit like the golden spine prickly pear that we saw back at the river. And it also looks a little bit like the Comanche prickly pear. And it turns out that those two plants may indeed be the parents of this plant.
So how does this happen? Well, it starts with a mistake. All egg and sperm cells are produced by splitting in half the chromosomes of the parental cell. One way this can go wrong is if this simply doesn't happen, and the cell doesn't divide, and it produces an egg with twice as many chromosomes as it should have. If a second plant produces a pollen grain that also has the same mistake, and they get together, voila, you produce a tetraploid. Twice as many chromosomes as the parents.
So chromosome doubling is a great way to form new species because you and I both learned in elementary school what a species is. The most commonly used definition is the biological species concept, which says that a plant is a species if it cannot breed with any other species. Well, if your parent species of a hybridization event happens to be diploid and you happen to be tetraploid, there's no way that you can cross back to your parent. You see, when you have the four sets of chromosomes to form an egg cell, that leaves you two. And when you have two, it leaves you one. And three just doesn't combine into an even number. It doesn't break apart properly during meiosis. So any hybrid that would be formed between a polyploid hybrid and its parents would be functionally sterile. It couldn't set fruit. So hybridization through polyploidy means that individual is now isolated from both of the parent plants and is on its own trajectory. It's already its own species. So here is an example, a fantastic example, of a plant that's in between two others, but has started to go its own way, has a different architecture, a different form, and a slightly different habitat, a little bit removed from the river, to become this incredibly spiny, crazy prickly pear that's before me, Opuntia spinosa baca. It's actually a really interesting concept, and it turns out that a lot of plants on this planet may have arisen through polyploid speciation events, just like this one.